Hey everyone, and welcome to this second lecture in the series of the topic sequences series. In the previous lecture, we started with what a series is, what list of number could be called a series. We looked at one type of series, that is the arithmetic progression. It is a series in which the terms are related arithmetically with each other. By addition and subtraction, you can find out whether the terms are arithmetically connected to each other or not, whether it is an arithmetic progression or not, whether the terms are progressing arithmetically or not. And then we went through different problems with that related to that, and then we derived a formula to find out the particular term, the value of a particular term in the arithmetic series. Now in this lecture we'll start with the new formula, derivation of a new formula, and that is how to find out the sum of n terms in arithmetic progression. Now the sum of n terms over here, I mean, is that n could be any number over here. For example, if you have a list consisting of 10 numbers, 10 terms, you can basically use this formula to find the sum of all the numbers. Or if you have a sum of 20 numbers, if you have a list of 20 numbers and you want to find out the sum of the first 10 terms, then you can use this formula to find out the sum of those first 10 terms. The way we do this is that we use this formula over here. Sum is equal to, this is not x, this is actually a multiplication sign. N is the term and it is being multiplied by the addition the sum of the first term and the last term. We know that this formula can be used as to find out the last term of the series. Just plug in the last value in n, the index of the last value in n, and then you can find out what the last term is, and then you divide the sum by 2 and then you can multiply it by n. This is how we find out the sum of the n terms, and we just plug in this value over here, we do our calculations, and we get this answer in the end, that the sum of this particular term, that is s sum, and the particular term n would be n divided by 2 being multiplied by 2a plus n plus 1 into d. So let's look at some of the questions. We'll be going through 3 questions in this lecture today for arithmetic progression. The first one is related to find the number of terms, that is the number of total terms of all terms that is in this particular arithmetic progression. Now the thing with this is that if you look over here, first of all we need to start with the things that we can infer from this series over here. One thing we know from this question is that this is an arithmetic progression, so we don't need to confirm that. But in order to revise our previous knowledge that we learned in the previous lecture, in order to revise our previous concept, we will first try to find out whether this is an arithmetic progression or not. So the way to find out that is through subtraction. So we basically subtract the second term from the first one. We subtract 105 from 100, we get the answer to be 5. We subtract 110 from 105, we get the answer to be 5. 115 from 100, we find out 110, we find out that the difference between these two terms is 5. We know another thing from this arithmetic progression, that the last term is 500. We need to find out the index of the last term, that is which term would make 500. Is it the second last term? Is it, let's just say the fourth term over here is 115, we can see that. Is it the 7th term which is 500, or is it the 11th term which is 500, or is it maybe the 69th term that is 500, or maybe the 100th term which is 500? So the way to do that is, of course, you can just keep on adding 5 and then you can say, okay, if I do this you can get 500. But another easy way to find that out is by the help of the formula. So what do we know what do we know about the things that we can plug in this formula? We know that a is 100, we know that d is 5, we just found that out, and an, that is the last term, that is the index of which we have to find, is going to be 500. So 500 is equals to 100 plus n minus 1 into 5. This is going to be our equation, and we're going to solve this, and we're going to get that it is actually this shows over here that it is actually the 81st term that would give us 500 in this arithmetic progression. So the 5th term is going to be 120, of course, and if we go on like this, adding 5 to each of the terms, we're going to get 500 in the end. Now let's look at the second formula that we learned today, and we're going to solve that right now. The sum of the 30 terms given in the arithmetic progression over here. So just like the approach that we used in the previous example, that is, we start with the stuff that we can find out. rather than the stuff that we don't know. So we start with the arithmetic progression over here. We know that it is arithmetic progression. We know that, okay, this is the formula over here, so we know we have to plug in the values. We need an D, we need an N, an A, and of course we need to find an SN. We know what the A is. The A over here is 12. We know what D is. 20 minus 12 would be 8, 28 minus 20 would be 8, 36 minus 28 would be 8. We just found that out. The common difference, that is, it's 8. We plug in 8 over here. So once that is done, we need to find out what is N. Now it is given in the question the sum of the 30 terms. So we just plug in N over here as 30, and then we move stuff around, we do our calculations, and we get the sum of the 30 terms is going to be 3690. So this is how we find out what a sum of a particular series is, of consisting of a particular number of terms, and this is how we find out what is the answer to the question of finding out the number of terms. Now let's combine both of these in the next example. Find the sum of the terms in the given arithmetic progression 2, 4, 6, 8 all the way up to 200. Now the first thing that the approach of course is going to be the same. That is, we first look at the stuff that we know rather than the things that we don't know. But in this scenario over here, there is a very big thing that we don't know, and that big thing that we don't know is that which term is going to have a value of 200. So we need to find that out. We need to figure that out before we can start. So we know the things that we know are A is equal to 2, that is the first term is equal to 2. We know that the common difference is actually 4 minus 2 because we can see it from the arithmetic progression itself. So now we need to find out which term would make 200, because through that we can find out the number of terms in this arithmetic progression, and then we can use the sum formula. So an is going to be 200 is equals to 2 plus n minus 1 into 2. We need to find out n, of course. We subtract 2 from 200, we get this, we move stuff around, and we do our calculations, and we get n minus 1 is equal to 99, n is equal to 100. Now that we know that the number of terms is 100, we can now use the sum formula. We need three things for the sum formula. We need an n, we need a, and we need a d. So we have all of that now. The only thing we didn't have before was 100, that is the value of n. So we plug in the values, we do our calculations, and we get the answer as 10100. So you see, another thing that I wanted to discuss with this point is that it's not necessary that you need to know the whole arithmetic progression, that you need to find out. In fact, you need to find out the sum of all of the arithmetic progression terms. What the question might come to you that there's an arithmetic progression of 50 terms or 50 numbers, and you need to find out the sum of the first 20 terms. So there's nothing to be afraid of in that. We need basically three things to find out the sum. We need n, a, and d. In that arithmetic progression in which you will have 50 terms, and they will ask you to find out the answer to the question that sum of the first 30 terms, A is going to be the same whether it's 50 terms or 30 terms, because A is concerned not with the terms that you're handling with. A is concerned with the whole arithmetic progression. So the whole arithmetic progression would have the first term as A. You would know that. Okay, secondly, I just want you to visualize this. So secondly, the common difference. Of course, the arithmetic progression is going to have the same common difference. The difference between the fifth and the sixth term, the fifth and the fourth term, the ninth and the 8th term, the 30th term and the 29th term, and the 45th term and the 44th term. The difference between all of this is going to be the same because it is an arithmetic progression. So once this is done, so you have D and then N. So now you see N over there won't be 50. Why N won't be 50? Because the 50 is the number of total terms in that arithmetic progression. But you need to find out, the question is asking you to find out the answer to this question, the sum of the first 30 terms, not the 50 terms. So you would plug in that case, you would plug in N as 30. So when you plug in that, you can get the answer to that question. So remember these two formulas and you'll do great in the questions. Another thing that I wanted to talk to you about was this term. If you want to find out the difference between two terms in arithmetic progression can be formulated in this way. Now this is just another way of finding, this is not the common difference, just finding out the difference between two terms of arithmetic progression, two terms that are basically, that are not necessarily right next to each other, they are not consecutive terms in the series. For example, it's not what you can easily find out the difference between the 5th and the 4th term, or the 11th and the 10th term, or the 16th and the 15th term. But what if you have to find out the difference between the 2nd term and the 29th term? So this is the formula for that, and the way to do that is this is the derivation of the formula. You don't just try to understand this, that nth term is being subtracted from the kth term. We represent the nth term with the n and the second term with the k. Of course, the formula for those terms, with the formula of the values of those terms is going to be the same. We just plug in n, we just plug in k, and we get the answer as nd minus kd. So if you want to find out and the final formula comes out to be this one. So if you want to find out the difference between the 2nd term and the 29th term, the way to do that is that you basically find this out. You basically find out n minus k into d. Try to keep n as the larger number over here, further down the arithmetic progression, because that way you can get a positive answer. For example, n could be the 29th term and the k could be the 2nd term. So that way, and if the difference between them is 5, you can basically write 29 minus 2 into 5. That would give you 135. So this is the way to find out the difference between the two terms. So these are the only 3 formulas that we learned today, that we learned in this arithmetic progression lecture. We have one more topic in the arithmetic progression, and that is the arithmetic means. Before we start with the geometric means, and then we end with the similarities and the relation between geometric and arithmetic means. So let's start with the arithmetic means now. So this is the definition of an arithmetic mean. Arithmetic means are basically what it means is that the terms between any two non-consecutive terms of an arithmetic sequence. We know what the value of consecutive, we know what the meaning of consecutive is. Consecutive is 17 and 10 over here, that are just after each other, 17 and 10 over here, and 10 and 3 over here, or 3 and negative 4. But what about if you want to find out the terms between the non-consecutive terms? What if you want to find out the terms between 10 and negative 11? What would come in between? So in order to find that out, this is called arithmetic mean. For example, between 10 and negative 18, there are 3 arithmetic means: 3, negative 4, and 11. We can see this from the series over here, but the question is going to be framed differently, of course. So these terms in between two non-consecutive terms are called arithmetic means. So between 10 and negative 18, there are 3 arithmetic means: 3, negative 4, and negative 11. Now the question over here is, find 3 arithmetic means between 8 and 14. So how do we do that? This is what the question is going to ask you. It's going to tell you to find out arithmetic means, and of course it tells us that we need to find 3 arithmetic means. So the way to do that is, first of all, you write it down so that you can visualize it. 8, then a space, and then a space and a space, then you can basically underline that is a blank, and then 14. In order to find out what the means, we need to know the common difference. We can use our formula to find that out, of course, like we already studied it, right? So we need to find out the formula, and we know that the first term is going to be 8, and we know that the last term is going to be 14, and the last term just happens to be the 5th term in the series. How do we know that? We can see it. We have visualized this. Through this we can see that the last term is 14, n would be 5, and the value of n is equal to 5 is going to be 14, and the first term is going to be 8. So once we have written this down, 14 is equal to 8 plus d 5 minus 1. What we don't know is the common difference. So we find that out. Once we found that out, the common difference going through this calculation that we did, the common difference comes out to be 1.5. So when we know this, then it's a piece of cake after that, because now you know that the difference between the second term and the first term is going to be 1.5. The third term and the second term is going to be 1.5. The fourth term and the third term is going to be 1.5. So you just add 1.5 to the previous term. You add 1.5 to it, you get 9.5. You add 1.5 to 9.5, you get 11. Then 12.5, then 14. So this way you can get the answer to this. Let's look at another example before we wrap it up. 72 is the dashed term of the sequence -5 to 9. We need to find n, which is the term number. 72 is an, we don't know, 5. -5 is a1, that is a is going to be -5, and the difference we can find out, that is 2 minus -5, that's going to 7. -9 minus 2 is going to be once again going to be 7. So the common difference is 7. -5 is going to be a, and the third term that we know is 72, which is going to be an. So what we need to find out is, we need to find out which term is the 72nd term, and the way to do that is from the formula that we learned in the previous slide. We just plug in the values and we just find out that the n is equal to the 12th term. So this is pretty much it for the arithmetic progression. We will be starting with the geometric progressions after this, and hopefully I'll see you guys then. Thank you very much.